My name is Ritika Dhyani and I am currently working as an assistant professor in AKGEC. Today's my topic in this video lecture will be graph theory, and I will be covering the basics, basic terminologies, and what are the different types of graphs in this video lecture. So let's start with, first of all, what is a graph? It is a set of points called nodes or vertices, which are connected by set of lines called edges. If we go with the standard definition of graph, then a graph consists of non-empty sets of vertices or nodes and edges. So let's take an example. As we can see here, this is a graph, and this graph is containing 4 vertices which are A, B, C, D, and the lines joining these vertices are known as edges. So here we can see that this graph is represented using this notation. This is the G for the graph, V for the vertices, and E for the edges. Here, if we can see this graph, then in this case, the set of vertices will be A, B, C, and D. And for the edges, it can be seen that this edge A to B is denoted by this notation, and similarly all the edges are written like this. Moving on to the what is the degree of a vertex. So in the similar graph, if we can see there for example, for this particular vertex, the number of edges connecting to this vertex is known as the degree of the vertex. So here we can see this edge and this edge is incident on vertex A. So the degree of vertex will be 2. Similarly, if we can here we can see for B it is also 2, because this edge and this edge is incident on B vertex. So here we can write 2. In case of C, this vertex, here we can see 1, 2, and 3. 3 edges are incident on this particular vertex. So the degree of this vertex is 3. Moving on to the fourth vertex, which is D, only 1 edge is incident on this particular vertex. So the degree of this vertex is 1. Next, even and odd vertex. As the name suggests, if the degree of a vertex is even, then it is called the even vertex, and if the degrees of the vertex is odd, then it is called odd vertex. So here we can see for A we have degree 2. So it is a even vertex. Similarly, the B also is also even vertex. But in case of C and D, we can see the degree is odd number, so both of these vertices are odd vertices. Now there is a concept of a degree of the whole graph, which is if the degree of a graph is the largest vertex of that particular vertex degree of that particular graph. So here we can see what is the largest degree here. C vertex has the largest or the maximum degree if we compare with all the other vertices. So the degree of this particular graph is 3. Next, handshaking lemma. In a graph, sum of all degrees of all the vertices is equal to twice the number of edges. So let's see this graph and see whether this particular handshaking lemma is applicable here or not. So here if we add all these degrees, so we have 2 plus 2 plus 3 plus 1, which is your 8. So the sum of all degrees of all the vertices, this is, we have 8, and the number of edges here we can see is 4. So sum is twice the number of edges. Yes, sum is twice the number of edges. So LHS equals to RHS. Moving on to the next topic, these are some basic terminologies which we used in graph theory. First one is pendant vertex. If a vertex has a degree of 1, then that vertex is known as pendant vertex. For example, in here, if we can see this vertex D has a degree of 1 because only one edge is incident on this particular vertex. So this is a, we can say this is a pendant vertex. Next, pendant edge. The only edge which is incident on a pendant vertex is called pendant edge. So here, if we can see, this particular edge is incident on the pendant vertex. So this edge C, D, this edge is known as pendant edge. Next is incident edge. An edge is called incident with the vertex it connects. So if we here we can see this particular vertex, this particular edge AC is incident on vertex A and vertex C. So this is the incident edge for these two particular vertices. Next is adjacent vertices. Two vertices are called adjacent if an edge links them. Let's say here, if we talk about this particular edge and this particular edge, both of these edges incident on the same vertex. So these are adjacent edges. Next, self-loop. Self-loop is an edge if it has the same endpoint from where it starts. So in this example, if I add an edge like this, then the starting and the end point is the same vertex. So this is known as self-loop. Next is isolated vertex. If a vertex having degree 0, then that vertex is called isolated vertex. For example, let's say we have a graph like this. And this is a vertex. So this is an isolated vertex because no edge is connected to this particular vertex. If here, if I say let's have another vertex, then these both of these are isolated vertex. Moving on to the types of graph. First one we have a null graph. It is defined as a graph which consists of only the isolated vertices. For example, let's say A, B, C, D. This is a graph and this graph contains only the vertices, no edges there. All these are isolated vertices. So this is an example of null graph. Moving on to the second type, which is a multigraph. If in a graph, multiple edges between the same set of vertices are allowed, it is known as multigraph. In other words, we can say if in a graph, it is having at least one loop or multiple edges, then that graph is known as multigraph. For example, let's say we have a graph like this containing the 4 vertices, and suppose there is an edge which connects vertex A and vertex D. Then because of this particular edge, this graph is known as multigraph. Why? Because there are 2 edges connecting the same set of vertices. So this is an example of multi-graph. Third one is undirected graph. It is a graph that consists of a set of vertices and edges, and the edge set contains the unordered pair of vertices. Let's see, for example, suppose this is the graph and containing these many vertices. Then here we can see V set is having vertex A, B, C, D, E. But the edge set we have for this particular edge AB, it is. Then for this it is BC. For this edge it is AC. For this we have CE, CD, and the last one is DEH. These are the set of unordered pairs because the position is not defined here, whether in this particular edge A is the initial point or the C. So this is how we represent an undirected graph. Moving on to the next graph, which is directed graph. In this case, the difference between the undirected and the directed graph is only this, that the edge set contains the ordered pair. What does it mean? For example, let's say we have this graph. So, because of these arrows, what does it denotes that it is a directed graph. So here, if we write vertices are A, B, C, and D, edges are, how we represent edges? A to D. So first we write A, then D, because for this particular edge, this is the initial vertex and this is the final or end vertex. So the position matters here. We always write the initial first, then final vertex. Similarly, we can write for this edge, here we have A, B. Then for this edge, it is B, C. And for the last one, we have D, C. Next one is your complete graph. A complete graph consists of n vertices in which each vertex is connected to every other vertex, and that is the edge exists between every pair of distinct vertices. It is denoted using this notation. In case of complete graph, we can calculate the number of edges by if the number of vertices are given using the formula which is written here. So let's see, first of all, example of complete graph is, let's say we have a pentagon structure and these are the vertices for this particular graph. Then in this case, for complete graph, every vertex is connected to every other vertex. So here, so this is the complete graph and this can be represented using K5. 5 represents the number of vertices. in the complete graph. For this particular structure, we can write the name as K5. And if 5 is the number of vertices which is given, then we can calculate number of edges, total number of edges, n minus 1 divided by 2. In this case, we have n equals to 5. So 5 minus 1 divided by 2, which is 5 multiply 4 divided by 2, that is 20, 10. We can see here 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So 10 edges are there. If we can, we calculated these edges using the given formula. Next one is a connected graph. It is a graph in which there exists a path between every pair of vertices. In simple terms, we can say if every vertex is reachable, then the graph is connected graph. There should be at least one edge for every vertex in the graph, so that we can say that it is connected to some other vertex at the other side of the edge. So this is the example for this particular connected graph. Here we can see all these vertices A, B, C, D, E, F, G, H and J are connected somehow. There exists a path. For example, let's say from A to J, we are having a path which is A to I and I to J, or A to B, B to C, C to E, E to F, F to G and J. So all of the vertices are connected using some of the edges. So this is the example of connected graph. Next one is disconnected graph. As the name itself suggesting that a graph is disconnected if it does not contain at least two connected vertices. It means, let's say, one of the example of disconnected graph will be for example, we are having A, B, C and D vertex. Here we can see the path exists for these three vertices, but the vertex D is not reachable from any of these vertices. So we can say this is an example of disconnected graph. Similarly, let's see another example where we are having the same set of vertices A, B, C and D, E, F. In this case, we can see this is one of the connected graph. This is another connected graph, but both of these graphs are not connected because there does not exist any of the edge between any of the pair of these two connected graphs. So we can say it is an example of disconnected graph. Next one is your regular graph. A graph G is said to be regular if all its vertices have the same degree. In a graph, if the degree of each vertex is k, then the graph is called k-regular graph. For example, main point here is if all its vertices have the same degree. Let's say we have an example here. This is a graph where degree of A is 2 edges are connected to this particular graph. Degree of B again 2 and degree of C. So all the vertices are having the same degree. that is 2. So this is an example of a regular graph. We can write it as we can write it as 3 regular graph. This is the name for this particular graph. Similarly, if we have a pentagon here also we can see that each of these vertices are having degree 2. Here also degree is 2, degree 2, similarly 2 degree, and this one is also having 2. So we can say all the vertices in this graph is also having the same degree. So it is an example of regular graph. Moving on to the next graph, which is a cycle graph. It is a simple graph with n vertices, and the condition here is n must be equals to or greater than 3. Because for a cycle, if we have having n less than 3, then it will not have a cycle. So the basic condition in this graph is n must be greater than equals to 3, and n edges is called a cycle graph if all its edges form a cycle of the length that is equals to the number of vertices. If the degree of each vertex in the graph is 2, then it is called a cycle graph. For example, here we are having n is 4, which is greater than equals to 3. True, condition is true. So this is an example of a cycle graph, and with the same we are having number of edges cycle form is also 4. So this is an example of a cycle graph. Next, moving on to one more thing, it is denoted using Cn. For this particular graph, we can write C, and n stands for number of vertices. So here we can write C4, which denotes this particular graph. Next one is cyclic graph. If a graph is having at least one cycle, then that particular graph is known as cyclic graph. Here we can see, for example, there are first one is this cycle. If we start from here, we are having this cycle, and again this cycle, and overall we are having this cycle, which starts from A and ends at the same point. So this graph is having 3 cycles. So this is a cyclic graph. Next one is your acyclic graph. A graph with no cycle. If a single cycle, even a single cycle is not formed, then in that particular case, we can say that it is an example of acyclic graph. So here we, with the help of example, we can see that from there is no cycle is forming. If there is an edge, then the cycle is formed, but this edge is not present here, so no cycle. Similarly, here there is no cycle present, so this is an example of acyclic graph. Next one is complementary graph. Firstly, we can find the complement of a graph, which is again a graph which has the same number of vertices as in the given graph and has 2 vertices connected if and only if they are not related in the graph. What does it mean? It means that, let's say we are having this example and there are these edges present. Let's say this is an graph. Then the complement of this graph must contain all these 6 vertices first of all. This is the graph G and this is the complement of graph containing the same set of vertices and the edges that it will contain are only those edges where the vertices are not related in graph G. For example, here we can see that these 2 vertices are not connected. So here let's add one vertex. Again, A is not connected to E also. So this is how it is shown. For B, F is not connected directly and E is also not there, for no edges there for E, and for D. Again for C, B and A, F, E, D all are connected, so no need to draw edge over there. For D, we are having C is connected, E is connected. Both F, A are not connected. So F and A is F already edge is present. For E, we are having F, C and D. So A and B are not connected. We already added the edge here for A and B. And for F, we are having here F is connected to A, C and E. So B and D is connected. So this is the complement for this particular graph. Next one is your labeled graph. In case of labeled graph, the edges are labeled with some name or data. For example, here, let's say we are having, this is the graph. If we write this is the E1, E2, E3, E4, then the edge AB is denoted using E1 label. Similarly, edge CD is named as E3. So this is an example of labeled graph where we label each edge with some name, or here we can also write, if for example, in case of we write 1, then this particular edge is 1, named as 1. Last one is your weighted graph. In case of weighted graph, if each of the edge is assigned a positive number, then that will be known as the weight of the edge. For example, let's say in this graph, weight of this edge is 4, this edge is 2 and this edge is 5. So these denoted the weights of the particular edge. So this is known as weighted graph. Thank you.